What is creep and how does a stress rupture test work? Have you ever wondered why some materials fail over time, even when they seem to be under manageable stress? This brings us to the concept of creep. Creep is a slow, time-dependent deformation of solid materials when they are subjected to constant stress below their yield strength. This phenomenon is especially noticeable at elevated temperatures, often when the temperature is around or above 40% of the material's melting point. Unlike immediate plastic deformation, which happens quickly, creep occurs gradually. Over time, materials can elongate or change shape under a sustained load. This is particularly critical for components like turbine blades and boiler tubes, which operate under high stress and temperature. Creep deformation happens in 3 distinct stages. The first stage is primary creep, where the creep rate starts high but decreases as the material undergoes strain hardening. Next comes secondary creep, where the creep rate stabilizes and remains nearly constant. This stage typically lasts the longest and is vital for engineers to understand how materials behave under long-term stress. Finally, there is tertiary creep, where the creep rate accelerates due to internal damage like voids and microcracks. This stage can lead to the eventual rupture or failure of the material. Now, how do we test for creep and its effects? This is where the stress rupture test comes in. A stress rupture test is designed to evaluate how long a material can withstand constant stress at a fixed elevated temperature before failing. While similar to creep testing, this test applies higher stresses to speed up the failure process. During the test, a specimen is subjected to these conditions until it breaks. The results are plotted, often as strain versus time or time to rupture versus applied stress, usually on logarithmic scales. These plots help predict how long materials can endure specific stress and temperature combinations before they fail. In practical terms, stress rupture testing is essential for identifying the limits of materials used in high-temperature applications. It reveals how long components can reliably operate before creep-induced failure occurs. Understanding creep behavior and stress rupture life is vital for preventing unexpected breakdowns in mechanical systems exposed to demanding environments. By knowing these factors, engineers can design safer and more reliable systems.